now the mic works. Okay, makes sense. Cool, hi, nice to be here. First one opening the stage, very cool. Afternoon, everybody eat good? Good food? Yeah, not too tired after lunch, because typically everybody's tired. No worries, I'll hype it up a little. I'll try to have you be entertained. Cool, so who am I? Well, that's a picture of me, of course. That is me. I'm the lead developer relations, of course, like Megan said, at React Bricks. I am an Astro maintainer. I used to work in the core team for a year, about a year, something like that. I have the BGS team. I work in the BGS team, which is a team that organizes conferences around the world. We have React Brussels, we have React Paris, we have React Africa soon coming up. So a couple of cool things that I do. Outside of that, I'm from Belgium. Anybody here from Belgium? No? Sad, because I also organize conferences there with my devs.gen team. And maybe I should also say what React Bricks actually is, because probably you don't know it. It's a visual editing CMS based on React components. Very simple. But I'm not going to talk about that. If you take any pictures or anything, please share them with me. I'm at Elian Codes on all platforms. So please share them, tag me, tag Astro, because it's always cool to see afterwards that there is a couple of pictures. What is Astro? That's why we're here today. What is Astro? Who has used Astro? Can I just, quick check? Not too many, actually. OK, that's really good. OK, because by now it's actually getting a little bit of bigger framework. It's getting more in like the common enterprise world, which is really cool to see. So let's dive a little bit into Astro. So Astro is a very comparable framework to Next or Nuxt. You have heard about those, right? Yes, OK, very good. But it has a couple of cool twists and tweaks and features. I'll just dive in. So this is basically what Astro looks like. It's a single file component, just like you're used to with, for instance, Vue. Or Svelte, maybe, if there are Svelte fans here. So basically, all of your scripting, your TypeScript, your JavaScript, all happens up top there in the front matter. We call that piece, like the 3 dashes at the top there, just like Markdown has. You can just import components there. You can write some variables. You can do fetches there. It all happens there. And all of your body is just normal JSX like you're used to with React or anything else. The cool twist, though, is with Astro that by default, you're shipping 0 kilobytes of JavaScript, because we compile all of it down to native HTML and CSS. So let's dive a little bit deeper into what I actually mean by that. So we have this page. This is a normal, let's say, I call it JSX or TSX. It doesn't necessarily have to be React or anything else. But typically, in a meta framework like Nuxt or Next, all of these components, like all the blocks here that you see, are representing different components. All of them require JavaScript to render in like the modern age. And that's totally possible. But the thing is, why are we actually doing that? Because all of these footer links, for instance, it's static components. It's basically links. It's maybe some static navigation menu. Why are we actually wanting JavaScript, and why are we using our resources to bundle that when we know that it's actually static? So what Astro does by default is taking all of those components that you write in JavaScript and changing that to be no JavaScript at all. It's just HTML and CSS, which is very cool. And this results in, of course, by default, a better performance, better SEO, in accessibility even, because it's just no JavaScript. It's not an empty HTML tag that you're sending with just an ID. No, it's the full HTML. And that's why we say that Astro is ideal for content-driven websites. It doesn't mean that it's only for content websites. It's ideal for them. But of course, I hear you thinking, like, what's different in Astro than it is maybe in like basically writing my website in HTML? Well, what if you need interactivity, or what if you want interactivity? You probably want a button to actually work. Like if you have your viewport and you scale it down to be a mobile device, you probably want a button that actually triggers something. Maybe it's an open menu. Well, in that case, we have client directives. And those client directives will actually tell you, or you will tell actually your component with a client directive how a component should become interactive and when it should become interactive. They give you full control. We have a couple of those by default. You can build your own if you want to, because we're open source by default. So of course, open source means that it's very extendable. It's very maintainable. You can do your own things with it. I'll explain these shortly. Like client load is very easy. It basically means, hey, I have a component here that needs JavaScript. Ship it as soon as it's possible. So that will always render JavaScript on the client whenever you need to. But client idle, for instance, is way more interesting. It will tell the component to wait until the main thread of JavaScript in your browser is free, and then only ship the JavaScript to that component. We also have client media, for instance, which you will give it a client media query, and that media query, once those requirements are met, it will ship the JavaScript to that component. We call it hydration. So for instance, that button that I was referring to, like a mobile button, it doesn't need to have any JavaScript if it's not on a mobile device. So once your viewport gets smaller and the button is actually visible, then you ship JavaScript to it. We also have client visible, but it's kind of same thing like client media. But client visible only works when a component is actually in the viewport. We use the intersection observer, if any of you know what that is. And then you have client only, which basically means, hey, I'm skipping out of the Astro compiler at all. Like, I don't need it. I just want it to be rendered as full on the client like you would do with React. So with the magic of client directives, we can take this empty, boring HTML page that we just had, even though it was all JavaScript, it's now HTML. We can tell it, hey, maybe my sidebar has a couple of interactive links, or this image slider, it probably has buttons and has to fetch some content maybe somewhere. And in that header, probably I have a couple of buttons there that have to be interactive or mobile. So with those client directives, we can actually just say, hey, only this component and that component and that component need JavaScript. Everything else, just keep it in HTML. So very easy. We call that mechanism, let's say, island architecture. And why do we call it island architecture? It's because basically your components that you have there are isolated islands of interactivity. Now, one of the cool goodies on top of that is that by default, Astro is framework agnostic. So you can use React on top of it, you can use Vue on top of it, and still if you don't tell Astro to use a client directive, it will still compile down to HTML by default. And that's why Astro is super full speed and is outperforming some of the other things on the market there. But of course, we have not been sitting still. Like this that I just explained to you has been there basically since Astro 1. We're now in Astro 4.x. But I'm here to tell you also a little bit about what we have worked on for the past couple of months. And it's actually pretty exciting. So I will tell you a couple things that are totally new, and maybe none of you, even though you might not have used Astro, or maybe you have, might not have heard of. The first one is server islands. And server islands is basically a different thing than we had islands before, island architecture. Island architecture has been a thing in Astro since Astro 1. But now we have Astro server island. So what is a server island? Basically, a server island is an island that you have on the server. So basically, you're instructing a component to delay the rendering until the fetching of that content is done. So your page itself will be rendered immediately, instantly, but it will fall back to some content. I have an example after this, don't worry. And it will basically wait until that fallback has loaded, you have your content, and then will only display the component. And it's super easy to do. Just like you had the client directives, you just add server defer, and that's it, that's all you have to do. And then in that component, you can do anything you would do in a normal component. So basically, you have access to the cookies, you have access to fetch requests, or maybe a database fetch. Whatever you want to do, you can do it in that component. And then you just add your avatar server defer. So that means this is a server island, wait until we actually have that content that we need, and until that time, show a fallback. So I have a pretty easy example here. This is a luxury island getaway. All of this is server island. So you can see, I think it will replay in a second here. Yeah, you see this is a fetching state. So it's still fetching the data from a database. It's still fetching some data. Maybe there in the top, it says how many rooms are actually left here. I need to fetch that from the database or maybe from another API. Show the fallback, show a loading state until we have that. And basically everything else is no JavaScript. So basically the only JavaScript that happens is the fetch from the client to the server that is Astro, which is a really cool technique. Something else that we just introduced is the content layer API. And it's pretty interesting because we had content collections. Does any of you know what content collections are? Yeah, only you. OK, no, that's totally fine. So content collections basically give you a way of working with authoring content. So you have a couple of articles that are all written in Markdown. And you want to display them efficiently. Well, we call that content collections. Basically, it's type safe and everything. But now we have constructed a layer on top of it, which is called content. What was it called? Content layer API, sorry. So what that actually does is it gives you the same flexibility, but also gives you a loader. And that loader you can do anything with it. Like if you want to load some content from an API, you can do that. For instance, here we're just basically fetching an API, then we have the response, and then everything will be collectible and will be collected as you go through it. And that gives you a super useful API that works very fast. Because now, if you just want, for instance, Cloudinary has one. Who has used Cloudinary before? Do you know what it is? Because if you don't know, no worries. Okay. So basically what Cloudinary does, it's an image service. So basically you have all of your images in a folder somewhere stored there. They will give you an API endpoint, and you can fetch all of the images from there. They will optimize them for you and everything else. So an image CDN. They have defined their own loader. So then you can say, hey, I want all of my assets loaded. In this case, I want only 4, and they should come from sample/food. And then you can actually use all of them with a super simple API in Astro itself. So now you can just get that collection, then you give it the collection name, which you defined earlier, and now you have just, CD image, give me this image, and done. Super easy API, super cool technology as well. Then we have Astro Actions. That's a new thing as well. Who has heard of Next.js Server Actions? Okay, well, it's very similar. Okay, cool. Good that you know that. Because it's almost the same thing, but it's just Astro native. Astro Actions basically allow you to reduce the amount of publicly exposed APIs. Normally, you might have a public exposed API for form handling, but it doesn't actually need to be exposed. It might just needs to be internally served, so why expose it to the public? That's basically what that can do. So, for instance, let's take a look at validating data. So you have a form somewhere, but you don't want to expose it to the outside world. Well, Astro Actions works very simple. So here, basically in the top, that's a different component than the bottom one. In the top component, you basically define your form. So it's just a form, you have a label, an input, like you would do in any normal form. You don't do any validation there. But what we are going to do is we define our action here in astro/action/index.ts. Yes, it's TypeScript. And then you accept the form, because it knows, hey, I need to form, I have some form data here. I need to validate the form data. And then you say, hey, give me the input. It's an email, and we use Zod for that. So if you ever use Zod, it's a very easy way of working like with validation. So it knows, oh, this email, it's a string, and it's supposed to be an email. And if that doesn't work out, it will return an error. Otherwise, it will say, OK, let's go through, and let's go to the handler, which probably in this case will be handling your email, writing it to the database, and handling everything else there. Now, how do you then actually call or do you link both? It's super simple. It's just with a simple script that you could do in JavaScript. Basically, you take the form, you select it, you add an event listener which does the submit, then you intercept it because, of course, you don't want to do the default action, which would be the action that is defined. There is none. And then you just say, hey, the form data is actually from the form. Let's send it to the action, and let's perform the action. In this case, it's the action.newsletter, which we defined earlier. And then if everything goes correctly, so there is no error, then let's navigate to /confirmation. And it's that easy to do. Now, the real cool thing that I want to talk about is AstroDB. AstroDB is a completely new concept that was invented over the last couple of months, and it's actually really cool. It's a first-party database API inside of Astro. So you can communicate with any libSQL database, which is basically a flavor of SQLite. So AstroDB is powered and built on Drizzle. So it should be very familiar if you ever used one of those ORM systems. It's pretty easy. And here we're just defining a table. We say, hey, we need a database. I want a database in Astro, and one of my tables is comment, and it has an author and a body, and I want it in my tables. That's all you do. This is defining a database. You can also do relations and stuff, of course, but I don't want to make this example too complicated. So what you then can do is basically, oh, list me now all of those comments. You just say, hey, comments, await database will select all from the comments, and then maybe join it with the authors, so we can actually retrieve the author name instead of the author ID. And then you map over the components, and you're done. The cool thing about this is you can even do this in HTML, because at build time, you can render all over them, and then just ship it as native HTML. No fetching required. And yes, this talk was actually labeled Astro Studio, all secrets revealed. But yesterday, we came with an announcement that actually we're sunsetting Astro Studio, which doesn't necessarily is a problem, because what we did is actually opening it up to any libSQL database. So for instance, Terso is libsql. You can just paste in your own credentials. So in this case, that's aliencodes.terso.io. That's the link. And then you have your app token, and it will just be open. Cool. And it will work with migrations and everything. Like it just works like it would natively worked or have worked with Astro Studio. But that's not everything. Of course, we also have Starlight. And Starlight, for the people that don't know what that is it's a documentation generator for Astro. It's really cool, it's really fast. It's basically like Docusaurus or VietPress if you ever use those, but built on Astro. And now it can do on-demand rendering, which is a new thing. Basically, it does server-side rendering on just some API endpoints. So for instance, here, you can add in your documentation generator, which is typically Markdown, you can add authentication, for instance, or maybe you want to fetch some cookies. You can all do it from the server instead of from the client, which actually would make more sense. Now, I hear it coming. What is next for Astro? Like, you have already so many features. You have cool things. We have heard about Astro 1, 2, 3, and 4. So next, maybe let's talk about Astro 5.0. 5.0 is going to be really cool. All of the features that I just explained are already available or in experimental, depends on 4.x. So yeah, major release, of course, we do a dependency upgrade. So I'm just going to go quickly over those because they don't interest you probably. We're going to up the node version to node 18.17.1 or later, and we're going to use the new Vite 6.0 beta. And Astro 5.0 will also still remain in beta as long as Vite remains in beta, which is quite important to know. We have new rendering modes. So we had basically static, hybrid, and server-side rendering. Actually, it doesn't make sense anymore. We are going to switch to just two, which is hybrid and server. And hybrid rendering means that all of your pages will be static by default, but you can tell each page to be server-side rendered by its own. So you can say, hey, this is an endpoint that I maybe want to be publicly exposed. You can just tell that page to be publicly exposed and rendered from the server. And we're going to do that by default. So that just means that in your config, you don't have to define it anymore. You don't have to define if you want a static website, a hybrid website, or a server website. It just means only if you want a server website that you can specify that. Everything else will just be the same as it was before. Now, content collections, I already told you a little bit about it. We're going to deprecate it, and we're going to use the content layer API, because it's just way faster, it's way more speedy, it's way more performant in build and in runtime. It's super easy to migrate to both, because it still, even though if you have content collections, it will be still supported in a sense, but it'll just be slower. But you can switch from one to the other in like 2 minutes. It's not a lot of time. Of course, we're also going to remove a couple of packages, and that's just not too interesting. It's basically the lit integration, but lit you can still do by importing a script, so it's very easy. Hybrid rendering is disappearing, as I just said. Squoosh, which is an image service, we're not going to use anymore. We're going to use Sharp, but like by default and only Sharp. And then we're removing all the experimental flags because they are stable now, which is a good thing. And of course, if you do a major, you're going to have breaking changes. But breaking changes, we have a full guide already on the go. So once you want to upgrade your website, you totally can. And you're probably wondering, Elian, when is the 5.0 release coming out? Well, 5.0 beta, because we're still in beta. And actually, it's 17 September, which is, yes, tomorrow. So it's a very exciting time for us. We'll see how it works. Upgrading is as easy as ever. It's just npx add astrojs/upgrade. And that will take you to the moon, because we're astronauts. And basically, I think that's cool. If you want to stay updated on all things that are happening in the Astroverse, even if it's your first time, you can check out the documentation on docs.astro.build or just astro.build. You can join our Discord on astro.build/chat, which is a super friendly Discord. We have a lot of questions in there, people sharing their contributions, people sharing what they build and everything else. And then there is only one thing to say, which is thank you very much, and hope to see you soon, I guess.